Hi, everyone. We are live. I think we're live. I hope everyone can hear me well because I have some technical difficulties on the screen. But yeah, I hope you're all doing great and welcome to another community call in our series of upcoming calls and events. We're going to have, I think, 5 in total community calls in the following weeks. So stay tuned for everything. Yesterday, we had a chat with our CTO, Marko Budiselic, where he talked about turning unstructured data into knowledge graphs. In case you missed it, we have it available on our YouTube, and I'm going to send links to all of that in a chat in a second. But today I'm joined with my teammate Ante, who was recently working on building an agent that helps you migrate your data from a SQL database to a graph database. Right now, we are in the middle of launching a lot of new exciting stuff with the AI toolkit we have. And we have, as I said, a few upcoming webinars, and I'm going to send links over to that as well to make sure that you stay tuned. And you can register immediately to that. As always, if you have any questions, feel free to ask in the chat, and we're going to have a Q&A session at the end of the presentation where Ante will answer all the questions you had during the call and the demo he will have. So now I hope you all enjoyed the presentation, and I'll let Ante introduce you to the topic.
Thanks, Matea. Hi, everyone. So today I'm going to talk about from tables to knowledge graph. This is quite important topic for essentially leveraging the knowledge graph in the RAG systems. So I will talk particularly about SQL2Graph agent that's performing migration. Before we kind of start, just to introduce myself. So I'm Ante. I work as developer experience engineer in Memgraph, and I do kind of a bunch of stuff related to this AI toolkit and MCP and recent initiatives about this. So what I'm going to talk today, I'm going to talk about different data models. I'm going to talk about RAG systems. I'm going to talk SQL and RAG systems. I'm going to talk about graphs and the RAG system, HyGM, which is Hypothetical Graph Modeling. And then I'm going to talk about SQL2Graph agent. And we are going to have a short demo at the end. So, if I ask you, like, what is the most common data model that you currently have in your companies, or that you're familiar with, or you're kind of currently using daily, you could have like multiple options. It could be a relational model, it could be multi-model, it could be key value store, it could be graph, document, etc. Some kind of search engine that you have on top of your data, depending on like what are you actually doing. But there is a high chance that you're essentially using a relational model, which is probably the most popular model out there. There is a reason for it. It was established in 1970s. There is like a huge historical foundation for the enterprise data in that type of model. Essentially, any type of SQL system is essentially a relational model, and there is a bunch of good systems out there that support relational model. So they essentially offer schema-based schema and kind of structure of the database. They're very consistent and transactional. They are matured and battle tested. Now, if you take a look, Postgre was released in 1996, which is like when I was born. So essentially, the whole ecosystem is matured. It kind of brings that enterprise data to the customers and the people using it. But today we all have like a different requirements from our data systems, and I guess if you are not living under the rock, you probably know what a RAG system is. But just as a refresher, it's essentially a retrieval augmented generation, which essentially combines the external data with the generation by the LLM. Here, the external data essentially is like your data stored, your data that you have. And the idea is that you probably, your organization probably has that good external data. The only problem is how to get it. Now, it is very important to get the best data, because if you take a look at this graphic, essentially when you are retrieving data, you want to retrieve the relevant information to provide the context to the actual prompt and the LLM that is trying to resolve the query you have passed to the RAG system. So you kind of want to chat with your RAG system and get that base data out. Why is the RAG system mergers getting so popular? There are like two reasons. The foundation models aren't scaling. I mean, if you follow the whole LLM saga, you will notice that the latest models are just a tiny bit better than the old models that came before them, essentially. But a lot of compute is spent on actual retraining of that. And as an average company, you probably won't fine tune your LLM models, which is quite expensive. And that's why a bunch of companies that are building the RAG system on top of your data. So when you have your backbone in a SQL, you essentially say, okay, I can build a RAG with a SQL, which is true. So you essentially take your existing data that is already in relational model, and then you can build a RAG system on top of it. The advantage is that you already have that data modeled in the SQL system, and you get all the relational advantages that we kind of briefly described. But there are a bunch of disadvantages in general. So one of the examples is joins do not capture the semantic meaning. That means essentially that you, in your SQL model, you're probably not modeling how this data is related. Vector embeddings do not carry relational context. So in the graph database, when you compute embeddings, you can kind of store the relation context also on the embedding. Not just that, but once you find like the interesting embedding, you can also use the graph hops to fetch the relevant data around that embedding, which you cannot do with the vector database, for example. And it's much harder to do it with the relational database. And joins do not scale for conceptual meaning, saying that you essentially, as you start to hop, you need to do a lot of joins that need to be that need to have that semantic meaning, and you lose that with the relations. Sorry, with the relational database. When I talk about semantic meaning, this is specifically what I'm kind of targeting is, let's say that you have this query, you want to select everything from the customers, but you also want to do two joins with the orders and products. And if you kind of take a look at the query, you're essentially kind of matching the IDs in the runtime to do these joins. So you're kind of comparing two sets, which is somewhat efficient on a smaller scale. And then as you're doing this, there is no contextual meaning to the, or semantic meaning to the, how these things are related. So for example, you could have like a relation between customer, order, product, which is totally unrelated to probably the first thought you had is like somebody placed an order and somebody purchased something, some product. It could be something completely else. While in the graph database, you would have like a customer that has placed an order that contains a specific product. So now this could be like a customer that has a complaint on an order that has this product. And now if you think about it, this completely changes like how your query looks like. And why is this important? Because it brings the context to that LLM. Important context. So this is why essentially GraphRAG exists and why the GraphRAG is important in that case. And for those who don't know, essentially a GraphRAG is a graph retrieval augmented generation, which means that we are leveraging a knowledge graph to get more context and more relevant information. So essentially, we want to get from the relational database to the graph database, and that has like a much more descriptive relationships. And that relationships can also have like specific properties. So, for example, an order can have an expiry if you are not able to deliver until that date. The order has expired, for example. So you can kind of start to complicate that graph use case much more. This is just to bring the point. And often people confuse the GraphRAG with unstructured data. So whenever you have a knowledge graph, any type of knowledge graph, it can be used as a GraphRAG. It's not just limited to the unstructured data. The reason for it, because Microsoft kind of popularized unstructured GraphRAG with unstructured data, and then it took off, and then people confuse it with general GraphRAG. So why Memgraph? Well, Memgraph, as some of you may know, is a high performance in-memory graph database, and we can provide a lot of context for AI. Reason being because we have a lot of different retrieval methods that you can leverage, like a text search, vector search, etc. And on top of that, you can do that hops, graph hops, and use those relationships that can have a lot of semantic meaning. So typically, GraphRAG pipeline in Memgraphs looks like a user asks a question, then you have like a context of the query, and then you are doing a pivot search or relevance expansion on top of your knowledge graph, and you are trying to answer the question to the LLM. But obviously, you're probably curious, why are we talking about this? So what often is the problem is that you have that SQL data, and you are building these new use cases with the GraphRAG and with RAG. And one of the problem is like even how to build a knowledge graph. And the problem is quite clear. So you need to understand the graph theory concepts, which I guess most of the engineers who went to some kind of education or have experience with the databases are somewhat familiar, but you need to know that. You need to have some graph modeling experience, and this is a pure art in a sense because it's much more. There is much more variety in how are we going to model. Is something a relationship or a node or a property, etc. It would be ideal if you have a graph database experience, because relational databases do not work the same way as a relational. So the graph and the relational database do not operate in the same way. Because one example is, if you want to leverage embeddings in a relational database, you need to use some type of extension. For example, in Postgres, it's a PG vector, and then you kind of compute on the row level, on the property level, on the column level, depending on how are you kind of going to compute the embedding. While on the graph, you can do also different things, like you can compute embedding on top of node, on triplets, and it's the modeling process highly impacts the overall system, and also the knowledge of how to use the graph database is quite important. Sorry. And the fourth part is essentially that Cypher experience. So you need to actually know how to move that data and how to model, etc. But yeah, those are all the barriers and kind of problems. So meet HyGM, and that's why we are talking today about this. That's hypothetical graph modeling. That's what HyGM stands for. It's essentially agentic-driven graph modeling process, which helps you transform SQL databases. In this case, I'm going to show you how to do it with MySQL. There's also support for Postgres, into an optimized hypothetical graph model. There is an open possibility for direct migration to SQL data to Memgraph, because we are creating a hypothetical graph model. As soon as you kind of use your SQL schema that you have and convert it to a graph schema, you essentially know how these things correlate, and you can perform migration. That's why there is an open possibility for that. And it is implemented in a SQL2Graph agent that I'm going to talk today. And why this HyGM approach is super critical, it's because the process of getting the SQL schema into the graph schema is super fast, and you are essentially kind of not spending time on modeling and how to do it, but rather you're letting the agent and the LLM to try to do it for you. So how does this work? Essentially, the agent proposes the hypothetical schema or hypothesis of how it thinks it should look like. Then you can validate, or you can kind of say, okay, I want to change this or this. But yeah, you have an option. And then the agent refines and you reiterate. So essentially, you are kind of in the driving seat, and the agent is trying to model the graph so that you can get from the SQL schema to the graph schema. So how HyGM essentially works is that you get the initial model, then we have the reasoning in terms of how would you kind of model that, like nodes, edges, etc. You accept you accept that, or you provide some feedback on nodes and relations, and the LLM then refines it, and then you validate the results in the end. So the whole idea is to get from the SQL model to the graph model as fast as possible. And it's all being implemented in the SQL to Graph agent. So the current HyGM implementation is essentially tied to that SQL to Graph agent. We would love to expand and pull out that HyGM experience throughout different products in Memgraph, maybe in MCP servers, so it's easier for the companies to get that experience of modeling in different services. But yeah, we are going to talk about more that in the future. But essentially, what are we leveraging in a SQL to Graph agent is Memgraph migrate modules. So we have different migrate modules that are capable of talking to Postgres or MySQL or other databases. And we are essentially preparing the schema, graph schema for the migrate module, and then we are just calling it. We are using a LangGraph to build the agent, and then we are also leveraging a database clients to actually connect and communicate the data in between. So the whole agent provides automatic modeling and migration process, while automatic modeling is the HyGM operation. Cool. Now I have talked about this, and we are going to try to demo it. So keep in mind two things as we are going to do it. There are LLM operations inside, so I hope that everything will pass well. But yeah, fingers crossed. So essentially, as Matea mentioned, we have this AI toolkit that we are working on, and this is essentially where all these things that we are mentioning is essentially located. And if you go to agents inside of that toolkit, there is a SQL to Graph agent. And this is essentially where this agent lives and can help you migrate the data. So to be able to migrate the data, you need to have a running Memgraph instance, which I currently have in the background. And if you take a look, it's currently empty. So there are 0 nodes, 0 edges, 0 indexes, and 0 constraints. So it's currently empty. And what I have is what I currently have here is, I need to select the table. Okay, so what I currently have here is Sakila dataset. And for those geeks that know MySQL, Sakila is kind of the basic demo of how MySQL database should be modeled. And it provides kind of the good practices of how to model your MySQL database. So I've used that as a kind of baseline for actually doing a migration. Obviously, you can design your SQL in quite variety of ways, but this is like a recommended approach. So I assume it's the approach that we should also kind of copy. Okay. So I obviously have MySQL running locally. There are these tables from Sakila that you're probably aware of. For example, let's show just describe actor. We are going to talk about the actor. And here is that table that is currently in MySQL. I have a Memgraph running, and I have the AI toolkit, specifically the SQL to Graph agent here. So the first thing that I would need to do before actually running this is I would need to create an end file to provide all the environment variables that I need to actually run this. They are all explained in the README file. I'm not going to go over the README, but you can kind of take a look. Essentially, the end file looks like this. Where it is? Why I'm not... here it is. has a dot in front. So essentially, the end file in the end file you can specify the key that you want to use. You can use like different providers. I'm going to use an OpenAI. So this is the example environment variable file. I'm not showing the actual mine behind the scene, but I have the actual OpenAI key here. You can use different providers. You can select different models. And then there are like a specific migration defaults, and I'm going to talk about it more. But essentially, you can kind of have a different mode, which is automatic or incremental. Automatic means everything happens automatically. You're not thinking about anything. That's a quite good mode. Then we have incremental, which means you are kind of in charge of driving and you kind of handle what you want to do. And there are different strategies. So we have a deterministic strategy, which is like a set of rules how the migration process should look like. And you're leveraging an AI or LLM for actually modeling that. Or we have an LLM strategy, which is completely LLM based. So you're essentially letting LLM kind of decide how it wants to do migration in a sense of a graph model. There are also the meta policy. So we are keeping track of in what part of process you are. Essentially, if you have migrated the data already, we are trying to merge it on top of already existing data. This is what the policy is, and logging, of course. Now you can select the different database. I will select MySQL in this case. And here you are passing essentially an ends to your SQL and ends to your Memgraph DB. So as I explained, I have both running locally, and I have set up already this end file, so I will not do it. I will just go and run the migration. You need to have UV installed and Python there. And now you have like you have started the process, and you're being asked what type of modeling mode you want. So essentially, I have commented out these two options. But if you didn't, you would essentially get that selection automatically. But for the purpose of the example, I'm now showing so that you can see what is happening. So I can say, okay, I want the automatic mode and I want the deterministic mode, which essentially kind of letting this go and trying to model and migrate data. And then if you go back to our Memgraph, essentially everything passed. And I can kind of take a look at the graph schema. And we have the Sakila data set migrated into Memgraph. So we have like 40K nodes and 109K relationships there modeled. And we can essentially go and take a look how the parts of that graph look like. So this is just a subsection of that graph that we got. And then like we can also get the specific node, and like here is the Penelope Guinness and actor with some properties. Okay, so what essentially happened is we created a bunch of constraints and indexes based on the SQL model, and we also created a different relationship between the different nodes and remodeled it to the graph and migrated the whole data in kind of 2 to 3 clicks. Now, I have mentioned the option to actually be in the driving state and model with the model in the process. So I'll first drop the whole graph just so that we have a fresh experience here. So that we can actually see our changes, what we have changed. So let's say that I want to go now into incremental mode, which means that we are going to review the changes. And let's for now keep it in the deterministic mode, which means that now we are being asked like what are we want to do. And for example, now we are processing a table actor from MySQL, and okay, we deleted everything, so there's nothing there. And these are the properties from the table. These are the node labels. These are the node properties that are being proposed. So this is that hypothetical model that we can influence. And there is a proposition of a relationship between actor and a film. So this is one of the possible relations. Now, let's say that I want to modify this. So I select 3, and then it asks me like, what do you want to modify? And I want to say like, let's drop the last update from the actor. And so the LLM is now applying that operation and dropping the last update property from the actor, and it has been updated. Let's also try to change relation, and let's say let's change the relation label from to acted in. Okay, now we have changed the relationship label from actor to film to acted in, which is actor acted in the film. And let's say we are kind of done. We don't want to change anything else here. Now it got to the another table, which is actor info. And in MySQL, you can have like these view tables, which are just for the read operations. And they don't have a specific unique data. And we are obviously skipping those because we have already modeled the actor node there. So there is just a copy of the same data. But essentially now what I will do, I will just skip, I will accept all the changes that the HyGM is proposing here. So essentially I'm saying, okay, I want everything, I want everything, I want everything, I want everything. And it's for each table, it's proposing the nodes and edges, and I'm just accepting currently. So I will do that for every table there is. Cool. And now we are currently in the summary and in the end, and we can kind of finish, or we can enter an interactive refinement loop, and let's see what is there. So we have an actor node. So here are the all nodes listed, 14 total, and here is the actor node, and it has the it doesn't have last updated property. And then there is like actor to film, which we have the acted in relationship. And also, since the film was a separate table, it also kind of take into account the relationship from the film to the actor and vice versa. So essentially, we needed to drop that relationship also on the film, but it's not important for our particular example. What we can do is we can also, in this last step, let's say that we don't want any unique constraints, and we can say drop all. Oh, sorry, I need to modify first. And drop all constraints. So what has been happening is we have been talking to the LLM or to the agent to actually change the hypothetical graph model here, and we haven't still got to the actual migration. So now we are kind of just interacting with that potential graph model. And what we did now is we run validation, and validation is failing because it says we have a missing property on the table actor last updated, which is, coincidentally is exactly what we did. Is we deleted that property, which is okay, and there is no constraints planned because we also changed that. So essentially, the validation process is saying, okay, you are making some kind of changes, and these are the problems, which is essentially what we did. So let's say that we are done and we want to accept and continue. Now, what should happen is migration should happen, and we should have all the changes applied. Again, we have like a set of steps and logs here, what happened and what the process was. And we are back to our Memgraph. And if you go to the graph schema and do a reload, so essentially we have that acted in relationship created. There's also actor to film because of the film table. We didn't say, okay, drop also this property because each table is looked in individually. But essentially, we have changed that. And if you take a look at the actor, it doesn't have last updated property anymore, which was the case when we initially had it in that graph. So if I run to get the actor, there is no last updated property anymore. So like with these steps, we can change different things. We can change the labels. We can change like anything in our hypothetical graph model, and get that data inside of Memgraph, where the agent is helping us there. Yeah, and for the last bit, there is also this there is also this um, uh, HyGM AI mode where it's essentially generating everything and the whole graph. I will now again drop the whole graph just to have a clean slate again. Okay. Yeah. And I will say, okay, let's do automatic and let's do HyGM LLM based. So essentially creating the whole graph. Now what is happening is LLM is suggesting again the whole graph model. There's no like deterministic rules by which it's created. There is like just do and create your thing, whatever you think is the right thing to do, and it try to essentially generate that graph model. Okay, so something failed. What happened? What is happening here is the LLM is proposing the initial graph model. We are running a validation, essentially looking how did we cover the tables, properties, etc. And after that, we are running the again we are running the generation of a new graph again. So what happened now is it finished. There are some problems. So for example, missing relationship type. But most of things kind of went well, which essentially means that LLM essentially kind of proposed that graph model, and let's just see how that graph model looks like. And if you take a look, like we got the relationships, we got the nodes, everything is inside Memgraph, and essentially the LLM proposed the graph model. There is a problem with it, with this film text node. It didn't connect into the graph, but essentially you can do it afterwards manually if it has like a film ID, and then you can kind of match the film ID to film text and create an extra relationship. But essentially you got this in like 3 clicks from MySQL to Memgraph, and now you can kind of have fun, or you can kind of participate in the process of changing that graph. Yes, so this is pretty much it, what I wanted to say. So about the demo, and then if you want to do it, you can obviously start your own Memgraph clone AI toolkit, go to agents SQL2Graph, run it the same way I did. Just make sure to create your end file, or you're going to spin a cloud instance. If you're going to do it in cloud, just make sure that your MySQL instance is also publicly available, because the migration modules that you're using are on the Docker container. And yeah, for the enterprises, if you are interested in the GraphRAG Jumpstart program, there is a link which you can kind of register and get help with kind of this type of things. Yeah, thank you. And I'm now more than happy to answer any questions.
Hey, sorry, I got kicked out of stage, so I hope you can hear me now.
Yes,
They
I
kicked
can
me
hear
out
you.
at the right time after my intro, so I guess that's all fine. But yeah, we had some questions from the audience, and thank you, Arthur, for the presentation. This was great. It was really useful to hear about this stuff. But the first question we have is from a user that says modeling is usually a one-time cost. Once I have finalized the relational to graph model conversion, what tools are available for ETL from relational database into Memgraph? So this is needed to keep the data in Memgraph in sync with the data in an SQL database.
Okay, yeah. So regarding the modeling one-time cost, it could be if your data model is not changing that much. But when we talk about the ETL tools, one of the things that we leverage here is that migration module essentially. So if you take a look at the migrate module, we have that for Postgres. Uh, but if you talk about keeping data in sync in general, like there is we have a Kafka connector for that triggers, and essentially it would be like setting up the Kafka connector to track the changes um, in Postgres and just passing that messages to the Memgraph database. So kind of CDC type of thing where you use Memgraph as a sink of those changes running from Postgres. But yeah, this SQL2Graph is more for like you want to do a GraphRAG type of thing, and you have your SQL data, and you want to do that modeling and migration kind of in a different ways.
Yeah. Uh, and yeah, another question is that this is a great tool to have, but the user is not sure if many people will be migrating from a SQL database to Memgraph, and do we see a lot of demand for that?
Yeah, so a lot of customers, as I said, and a lot of community users and in general systems are built with relational tools. So essentially, when you want to perform any type of graph reasoning on your data, you essentially need to kind of create that knowledge graph. And this is a lot of time, like a steep curve to start on. And that is the reason why essentially this should kind of help out. I mean, a lot of different companies are doing different things with SQL and with Memgraph. But yeah, this is one of the possible pathways that could ease that process.
Yeah, and I would like to add that Ante and I are really active in our community, and we talk to users a lot on Discord and office hours calls. So we heard multiple times that people are using a SQL database because they are used to that, but they are aware that their use case would thrive in a graph database. But that learning curve and that, as you said, like steep climb to actually migrate your data sometimes can be too much. So this is a great tool to use if you just want to build maybe a POC, or you just want to see what an agent can build from your relational data into the graph database. So I would say in that case that this agent is built for that. But yeah, great question. The next one is so from Miguel. What LLM model that can be run locally on a single GPU do you suggest people use to convert natural language to cipher with best results? For example, in a graph chat.
Ooh, this is a hard one. So this is a hard one because by saying a single GPU, I'm assuming something not that huge. So essentially, that means that you need to find an open source model that can be run on your GPU, and actually, um, I would stick with the most popular providers there. Like the OpenAI has its own open source models, but the Meta's Llama is also a good choice. But again, it is questionable how good can those local models or those smaller models essentially generate that cipher. What is interesting, if you are solving that problem, if your LLM, local LLM, can support an agent mode, I'm not sure like how many local models essentially support it. That means that your cipher generations can be retried multiple times by the agent, and this means that your LLM will do trial and error until it kind of comes to the possible solution. So I would look at the two requirements. One is what can be even run because it depending on the GPU. So what models are kind of the options, and what of those has an agent support mode. When I say agent, so that the LLM is capable of running in agentic loop. So the agentic loop is like LLM doing a reasoning thing. So it plans to do several steps and then it retries on some step.
Mhm. This is a question we get often, but it's quite subjective, especially when choosing LLM models. So
Yeah.
yeah. The next question we have is it redundant to have a SQL database in addition to a graph database, or could an application rely entirely on a graph database?
So, as with any kind of tool, there is a tool for each purpose, and people use different tools for different purposes. The graph You can definitely use the graph database for any type of application. So essentially, you can use it to solve different problems, and there could be some type of redundancy there. But essentially, as soon as you kind of start hitting the limits of any system, you are obliged to essentially migrate to the, or kind of add additional system that will support the feature set that you need. So the short answer is it can be redundant, but the application can definitely depend only on the graph database if you want that.
Yeah. I think that's all the questions we have from the audience. If anybody has any other question, feel free to post it in the chat. But yeah, maybe one question from my side. So let's say I'm coming from a SQL database user perspective, and I want to get started with migrating my data. Do you have any best practices in this case? Do I have to maybe change my data in some way? Do I have to do any of the pre-processing before getting into this, or any general best practices?
No, so the whole idea of this is that you don't change your model from the SQL side, that you change it just on the graph side, essentially that you hypothesize with the agent to get the some kind of graph model. Once you have your data into the graph model, then you can start to think about like how can I even model this a bit better, and then you can maybe retry with the agent and say, okay, I want to change this thing and this thing, and then after a week or 2 weeks, you kind of notice, oh, I could model this way because of this type of query, and then you can also retry the agent. So I think that it's much better to just try it out and to see how it goes than trying to prepare something in advance.
Yeah, so the general idea is if you want to let the LLM do the work, you have minimal manual labor here. So yeah,
Exactly.
you have nothing to lose, including the time.
Yeah.
That's always great today. But yeah, I think that's all the questions. It was a great presentation, Ante, and the live demo gods were on your side today, so
Yeah.
that's always great. But yeah, I hope everybody enjoyed it as well. As always, we're going to have it available on our on-demand page. I'm going to send the link over in our chat, so you can rewatch it there in case you missed anything or you're just watching it for the first time. But yeah, our next webinar is with our colleague Tony on the next Wednesday. Oh, sorry, Tuesday, not Wednesday. So that's less than a week without us. But yeah, sorry, I see one more question if we have time, but we do. So Andreas is wondering, you mentioned external services. Do you also support Olama Happy like GraphChat? It was probably API.
Currently in the SQL2Graph agent, the Anthropic, the OpenAI, and Gemini are supported. But if you need Olama API support, just open an issue for that on the repo, and we can do it essentially. No worries there. It will eventually come.
Yeah. Okay, great. Thank you, Ante, again, and thank you everybody for joining. And I'll see you on Tuesday at the same time and the same place. Not the same place, different link. See you
Thank-
all.
Thanks for
Bye
coming.
bye.
Bye bye.